Kia ora Year 12. Here are two questions from yesterday's little test from the 2016 A-level paper, and it's paper 32. So the first one should hit you pretty quickly as an integration by parts question, and we have to find the exact value of the integral. Now the reason why I look at it and straight away see that it's going to be IBP is that here I've got sine of 2x, and here it's multiplied by x squared. So unless this thing here is the derivative of the inside function, it's probably going to be integration by parts. A couple of you tried to do substitution on this, and some of you chose the wrong thing for differentiating and leaving. So let's have a look at it now. So it's the integral from pi on 2 to 0 of x squared times sine of 2x dx. Now we have to choose which bit are we going to leave or differentiate, and which bit are we going to integrate. Well, they're both pretty easy to integrate, but when we differentiate, this will get simpler. So this is the bit that we're going to leave or differentiate, and this is the bit that we're going to integrate. So leaving the x squared and integrating this gives me something times cos of 2x, right? So cosine differentiates to negative sine, so we need to have a negative here, and the derivative of 2x is 2. So we have to undo the 2 by multiplying by the reciprocal. And we've done that over and over. Now, some of you are still mucking this up and you're putting the wrong coefficient here. The most common mistake is to put 2. That means you need to do some fluency work in the old Delta textbook or use Dr. Frost. So that's the first bit done. Minus, and now we're going to have the integral from pi on 2 to 0 of 2x times negative 1/2 cos of 2x dx. I'm going to evaluate this now. I could go the whole way through before I do that, but here I'll get on with it. And to do that, because we're going to be substituting into a cosine function, I'll draw a really quick sketch of that. So I'm going to have pi on 2 squared times negative 1/2, and then cos of pi is negative 1 minus, and then I'm substituting in 0, so it's going to be minus 0. Now cleaning this up will give me plus the integral from pi on 2 to 0 of x cos of 2x dx. So the first bit here, this evaluation, gives me pi squared divided by 4 2's are 8. And here I have to do IBP again on the integral. So this one I'm going to leave or differentiate, and this is what I'm going to integrate. Okay, so we've got pi squared on 8. Integrating this will give me, so leaving this gives me x times 1/2 sine of 2x minus the integral from pi on 2 to 0 of 1 times sine of 2x times 1/2 dx. Okay, so that's the integral of this, is what's coming in here. That leaves me with pi squared on 8 plus 0, substituting in here. So the first one, oh sorry, that's not obvious yet. Let's slow down. So for the substitution, be pretty careful with it. We've got pi on 2 times 1/2 times sine of pi minus 0 times blah, blah, blah. And then here, when we integrate this, we're going to have cos of 2x. We've got 1/2 there. And we're going to have negative 1/2 here to get me back to positive sine. Right, so because this is an exam video, I'm not going through all of that even more slowly. So if you're not confident with that, it's time to go and get on with that work. So we've got pi squared on 8 plus, now what's sine of pi? Well, sine of pi is just 0. So got 0 take away 0 plus 1/4 of cosine of pi minus cosine of 0. So pi squared on 8 plus 1/4 cosine of pi we had from above is equal to -1, and cosine of 0 is +1. So as usual, you have to be really careful not to make sign errors when you've got trig functions. So it's pi squared on 8 minus, let's see, something's gone wrong there. Yep, cosine of 0 is not -1. So you can see that I stopped myself just in time because I had a negative sign in there. And so here we've got plus or minus 2/4, so we've got -1/2. So that's the first one done, and done pretty slowly because there are a lot of places that people are still making small mistakes. So make sure you're starting to get rid of those. Then the second question is also one where it's pretty easy conceptually to see what to do, but it's very easy to make mistakes near the end. Just note that we have to find exact values in here. So my function is, where is it? Just a sec. Okay, my function is y is equal to the natural log of x squared divided by x. For stationary points, we need to have dy by dx equals 0. I wasn't asked anything about the nature of the stationary point, so I don't need to look at the second derivative. I just need to solve and figure out where the gradient is 0. So to find the gradient here, I'm going to use the chain rule. I'm going to start by squaring the denominator and then timesing x by the derivative of the numerator. So it's going to be 2 times ln of x times 1 over x, doing the chain rule on that, right? Minus the derivative of this, so minus 1 times the natural log of x squared. So this cleans up to give me 2 ln of x minus ln of x squared over x squared. And that equals 0 when the top line is equal to 0. And that will happen when log of x into 2 minus log of x is equal to 0. So two solutions here. Ln of x is equal to 0, or ln of x is equal to 2. Remember that ln just means the natural log, means the log to base e. So here, this one should be feeling very easy. X is equal to 1, right? Over here, we've got e squared is equal to x because of how logs work. So I'm not quite finished though. I've got my x coordinate, but now I need to get my y coordinate for both of those. So going back to the start, remember y was equal to the natural log of x squared divided by x. So here y is equal to 0 squared on 1, which is 0. So my first stationary point is 1, 0. And here we're going to have y is equal to the natural log of e squared over e squared. Now the natural log of e squared we can rewrite as 2 times the natural log of e squared over e squared. The natural log of e is just 1, so we have 4 over e squared. So my second stationary point is e squared and 4 over e squared. And we were asked for exact values, so you will get no credit for shoving that into your calculator. All right, hope that makes sense. Can't do any more because the dog is doing some very dodgy things. I will be back later. Thanks for watching.